Alright troops, Yoker Uni presents Physics. Hola, como está, man? I'm just back from my summer holidays. Santa Ponza with the troops, man. Valdo here to give you some more jaw-ripping physics for the new school year. No danger, wee man. Right, we're going to do gas laws, because gas laws are pure part of higher physics in Scotland, and they are heavy boring, by the way. That's cause physics teachers pure take forever to teach about it. It's actually a 10-minute job, but you get all these pure bought-in teachers flashing their knowledge, thinking they're pure Einsteins. You might have heard about KISS, keep it simple, stupid. Well, we use a different one in Yoker, kebab. Keep it basic, alright? Bottom. It's cause of these bottins that gas laws have been heavy bumped after the higher course. I feel sorry for them, so I'm going to teach you about them, since you need to still know about it for this year, alright? When I talk about gas laws, I'm talking about physics of a substance in gaseous form. I'm not talking about gas laws for society, like whoever smelt it dealt it, or silent but violent, or Deckel's let one drop, you can't go back in the room for 20 minutes. It's not as catchy, but Deckel's diet is a pure shocker, and he has been known to kill small animals through his farting. Wee Smudge didn't make it the room in time once and was pure knocked unconscious. So when I talk about gas laws for physics, I really mean the three laws that heavily describe how pressure, temperature and volume all fit together with an ideal gas. An ideal gas just says that when all the wee particles of the gas that fire about and bounce off the walls of each other, when they do this they don't lose any energy. That's all it means. I'll tell you about collisions and momentums and all that stuff later on. Right, so there's a couple of equations called the ideal gas law, but it's pure been taken over by the chemistry buttons with their pure numbers of moles and Avogadro's number and all that rubbish. Leave the numbers to the big boys in physics. We don't want amateurs like chemists thinking they can flash the maths about in science. Away and play with your acids and your stink bombs and your fume hoods. All these wee mad bits of the equation just tell us about the mass of the gas. For our purposes, we're not going to change the mass. So we just get the same number of atoms and all that stuff, alright? So here it is then, for a fixed mass, the pressure times volume divided by the temperature equals a constant. This means that if we look at the same bit of gas a wee while later on, even though some of the things might have changed about it, the pressure times the volume divided by the temperature is going to equal the same number as it did before. This is a pure easy way to write your ideal gas equation for higher physics. One thing to remember though, and that's that this equation is about as much use as a one-armed trapeze artist with an itchy bum, unless she's pure use the Kelvin scale for temperature. If somebody gives you your temperature in Celsius, just add 273 to it. Remember wee man, 0 Kelvin is minus 273 degrees Celsius. Right, let's take a swatch at the laws then. Law number 1 is Boyle's Law. This is named after Robert Boyle, who was some mad Irish guy who found out that pressure times volume is constant when your mass and your temp are kept the same. Double your pressure, then you need to half your volume. European bottons call it Marriott's Law, but we don't. It's Bobby Boyle's Law, and that's that. Number 2 is Charles's Law. This is named after some mad Frenchy guy called Jacques Alexander César Charles. Some say it should be called Amonton's Law, because he actually did all the work years before. But Charles published his work, so I guess you snooze you lose, big chap. Charles's Law it is then. This law says for the same pressure that as your temperature increases, your volume increases too. Double your temp means you need to double your volume. Law number 3 is the imaginatively named pressure law. Nobody knows why this didn't get a name. Sometimes people call it the Gay-Lussac's law, but there are two heavy, massive reasons why we don't call it Gay-Lussac's law in Scotland. 1. Gay-Lussac didn't have anything to do with the work with this law. If anything, he did all the research for Charles's law, but well after Chico did. And 2, can you imagine your physics teacher standing in front of a class in Scotland and saying there's a law in physics called the Gay-Lussac law? No, didn't think so. This law just says that for a fixed volume that your pressure divided by your temperature is constant. Double your pressure, then you double your temp. For physics, you need to be able to answer questions on a thing called the kinetic gas theory. All it is just a pure fancy way to describe how these gas laws work when we think about the actual mad wee particles of the gas itself. A question could be, how comes, wee man, when you pure increase your gas temperature, that your mad pressure goes up and all? This was actually taken for a proper SQA exam paper. To pure answer it, just remember the following things you need to mention. Temp goes up, so the average kinetic energy of the particles goes up. So does their average speed. This means they'll be pure hitting each other, but especially the walls of the container even harder than they were before. This bigger average force over the same area means that your pressure goes up. Simple. You need to pure adapt this wee list when answering about pressure and volume or temperature and volume, but I'm sure you can ask your physics teacher if you need help. May as well use them for something, they get paid enough money anyway. Alright troops, I'll see you very soon. Thanks for tuning in. Catch you Versace.